So I have the aluminum strip here, and the edge has been trimmed in order to get as even a width as possible. So now I'm going to measure the width. Put a little tape down on the end here and at the other end in order to keep it straight as I'm measuring. So you can see there's just a little bit of tape right there on the end. I don't want to cover too much of it up with tape because later on I'm going to put an alligator clip to it and I need to run current through it, and so I didn't want to lose much of the current carrying the strip because of tape. And then at the other end, there we are at the other end, just a little bit of tape just to keep it straight as I measure the length. I'm going to measure the length of this aluminum strip. I got the two ends taped. And I want to make sure that this end of the measuring tape is flush with the aluminum strip. So I'm going to push it a little bit farther than it should be. Push it a little bit farther than it should be, and now I just sort of push back. And it's too far. And yeah, I mean, does this make a huge difference? No, but I'm hoping that the attitude of precision measurements here carries throughout. I think that does it. There. All right. And then down at this end, you can see where that hits. And you should be able to get down to the estimated digit. And there you go. So 0 was at the other end, and this end is obviously somewhere around there. Finding the width, I have a ruler there. We're using the metric side of it. I want to make sure that the ruler is normal to the aluminum strip. And I'm going to push this edge. Let's get that in the middle there. I think that 2 is lined up there. And so now you can see what the thickness of this is. That should probably be easier if I took pictures. Alright, so now doing the other side, just picking a different starting point, just people don't get too complacent over the same values. Alright, so that one is where the left side is lined up and the right side is lined up there. And let's pick a spot in the middle. Again, I want it perpendicular. All right, they should be relatively close to each other. So we have length and width now. So we got the aluminum foil in there. So let's confirm that the number of folds, so that's 1, 2, 3, 4, 5, 6 folds. Now we're going to find the mass of the aluminum strips, so we need to make sure that this is lined up on 0 right there. So I'm going to come back when I've got that lined up, when there's nothing on there. Oh, actually, let's make sure that all these are off to the left, which they are. Okay. And in order to get it balanced, I basically need to take an offset into account, because the aluminum strip really has an incredibly low mass. And so I can do it 2 ways. I can stick something on here to make sure that it's above 0, figure out what the mass of that is, and then put the aluminum strip on top and just do the difference to find the actual mass of the aluminum strip. Or, so there's a knob right here for fine adjustments that I can also use in order to, if there's just a small difference, which there is in this case. And as we look at it, and the question is that lined up? I'm thinking it's just a little bit off. So I'm going to adjust this again, and I'll be back. All right, so looking there, that is looking lined up to me. So this is when there's nothing on the balance, and the triple beams are all set on 0. So now let's put the aluminum strip on there and see how little mass it has. So I tried incredibly hard not to bend it or crease it. That's just, I gently rolled it. And so now the balance is off. And so I will be back in a moment. And so now we can take a look at that. And that's looking lined up to me. And then we come over here to the measurement. And there it is. All right, so when I was dealing with the aluminum strip, trying to put it onto the triple beam balance, the way I basically did it is I have it draped over my finger right there. Again, I want to put as few creases in this as possible, so I have it draped over my finger, and then I just draped it again, draped it again. Again, not putting as little pressure on it myself, other than obviously I'm holding it up, so I'm applying some force to it. And then delicately putting it on here. Had it on a little bit differently before, but I should get the exact same value. Let's find out. And it's looking pretty well lined up there. And then to here. And that's where it was before, because I actually had not touched that from the previous demonstration. I've attached alligator clip to this end. We'll eventually have a wire connected in there and an alligator clip at the other end. I'm going to tape these ends down and then measure the distance from the inside tip here to the inside tip of the other one in order to figure out how much the current carrying length is. So the assumption is that most of the current is going to flow to the end of this and then flow onto the strip, and that I don't need to worry about this. In terms of spreading out, because if electrons come in, they will spread out, but there are enough issues that we don't need to really worry about at what point are they really taking up the full width here. You notice there I've got the end of my measuring tape and the end of the alligator clip, and I want those to touch. And so those are touching. And also I'm pushing it in there so that this piece has a little bit of give on purpose, that the amount that it gives should be equal to the thickness of this clip right here. And so when you're measuring, you either hook this on there or you push. And so I'm doing the push. And then we're over here. And so now we want to see where the tip of the clip here lines up with a measurement right above it. So let me get that centered. And you should have a pretty good feel down to, well, let's see if we can get that a little bit better. I think you can take it from there. Well, you definitely can get within a millimeter. So now we're at the point where we're going to try to find the resistance of that strip that you can now see laid out. Again, this is not the final setup right here. This is just part of finding the resistance. And so step one, the first resistance you're going to find is theoretically using the formula as well as the known resistivity of aluminum. Now, the next step is we are going to find the resistance using the multimeter, which are over there right now, from there to there, and see what we get. Now, in order to do that, we do need to disconnect this from the power supply, because that would have some resistance in there also, which would probably be pretty big. So basically we'd be finding those resistances in parallel, and that would be the dominant resistance right there. But the subtleties, the little things make a difference. So I'm going to disconnect there and set up the multimeter. So I'm going to disconnect the multimeter, as seen right here, from the alligator clips, and then I plugged wires from the multimeter to the alligator clips. And now let's just see what we get. It should not be a very big number. So finding the resistance, I've taken the plugs that were in the power supply and I moved them into the ports there. And yep, it is what it is. All right, so looking at a second multimeter, and we were getting those values. It is flipping back and forth between two. You can come up with an estimate based on how much time it spends on one than the other, in my opinion. It's not an official technique, but based on my understanding of how it measures resistance. So I'm going to leave it on there for a bit so that you can come up with a decent estimate if you're doing that technique. This is a third multimeter right here, seeing what kind of resistances we get from this one. And again, those numbers seem a lot higher than I would expect, but you can be the judge about which resistance you take. That's why we're finding resistance several different ways. Now, in terms of the resistivity of aluminum is potentially slightly different than the resistivity of aluminum foil. Aluminum foil is not pure aluminum because it wouldn't be easy to put into foil form. I have some aluminum in my office, and it basically is disintegrating over the course of several years. I need to put it into a baggie. So there are some impurities into it, but the impurities are on the order of 0.1% or in that ballpark. So the impurities are not changing the mechanical properties of aluminum significantly most of the time. All right, so from that, hopefully you can come up with an estimate. So we'll be doing the next technique for finding resistance, looking at Ohm's law. So this is going to be measuring voltage, so I'm going to put that on volts. And when I set it up, I have it set up in parallel with the two outlets right here. So whatever the voltage is between here should be the same voltage as between here. And then I need to set another multimeter up to measure current. And when I measure that current, I need to put that on the 10 ampere because we will be dealing with large currents. Now the 10 ampere seems to be relatively accurate until you get to about 200 milliamps or 0.2 amperes. So as long as we are bigger than 0.2 amperes, then I am going to be using it. Anything that drops below that I don't consider as accurate, and I will move to a different voltage. So this is going to be measuring current. Any current that's going to be flowing through the aluminum foil will have to flow through here. So this is hooked up in series, and the current's going to flow around there to the black wire and then back into the power supply. And so that's the setup. And so I just need to make sure that this is set up so that you can see both of them at the same time without any glare. This is what we'll be using for measuring voltage. This is what we're going to be using for measuring current. It's on the 10 ampere setting. Oh, and this needs to be set over here. It's the only time we use that left port. There we go. So we got those two set up right. It's on the 10 ampere. This one is on voltage. And so now let's turn it on. We got the red light on, so looking good right there. Let's find out first at what point it will trip. Now there's a negative sign there, so I'm going to flip some. Let's redo that. What we're going to do is find the resistance using Ohm's law. This is the one that's going to be used for measuring voltage. That's the one that's going to be used for measuring current. So voltage, current. This is the one that's set up in parallel. This is the one that's set up in series. So what we're going to do is we're going to turn on the power supply. You should see the red light come on, and then we're going to crank the dial. First, we're going to figure out the point at which the breaker flips, and that's the point in which we need to make sure we are below. So it's on, the red light is on, so we're looking good right now. And you can see that those numbers are changing. There we go. And that's the point where it stops, just shy of 50%. And so my first measurement will be at 40, and then if I just drop by roughly 5% every time. So this is roughly the percentage. So if you're for this type machine here, which is the not X-Tech, it's the Fisher Scientific, then those are the numbers you can be reporting for the percentage aspect. So we turn it back on, and you can see it's on DC, and the number is going to be flipping. There's a certain range that the voltage is going to be doing. This is not actually a steady voltage. We held it on there too long, so let's do that again. So when you see the flipping numbers, just pick what seems to be the middle value. So we have current here in amperes, and then we have the voltage here. So pause it if you need to. And I'm going to try to put it at 35%. It's somewhere around there. So the voltage has dropped as we expected, and the current has dropped as well. Right, now the next one. So that's our third measurement. Our fourth measurement, still in amperes, still in volts. Our fifth measurement, our sixth measurement, our seventh measurement. Now we are still above the minimum before it becomes questionable. So we did 10, 15, 20, 25, 30, 35, 40. So that should have been 7 measurements. All right. Now the next step is that this is taking the resistance of several things, not just the aluminum strip. So we need to redo it again without the aluminum strip involved and see what kind of results we get. So I'm going to turn this off and set up for the next bit. All right, first let's make sure that we have set it up correctly. High potential port, low potential port. So in parallel to that, I have the meter that I'll be using for voltage. And then the current's going to flow out of there through this wire right here into the meter I'm going to be using for measuring current. And then into here, that's what the aluminum strip was between those two clips, and then back into there. That is set up right, and that beeping sound, if it happens to make it into the final edit, is coming from the meters which are about to shut off to save power. So now I will pause this and set up for the actual measurements. All right, so here we go. This is the checking of the resistance without using the aluminum strip. This should give us a baseline. Now, we don't have to use the exact same values because we will be comparing the slopes of these two graphs, and the difference of the, not necessarily the slopes, but the difference in the resistances that we get from the two slopes should be the resistance of the aluminum foil. And that is on the wrong thing. There we go. So we have a voltage here in millivolts, and we have current here in amperes, and that is, well, you can read the dial there. So now I'm going to move it up a little bit. This is still reading in millivolts, that's reading in amperes. Let's go up to the next one. So this will be our third measurement. So we're now on our fourth measurement. Now on our fifth measurement. This is in volts, and I hope you can see that, but you know, there is a general progression. So if it goes from 500 to 0.2, pretty much figure that's going to go from millivolts to volts. All right, so our sixth measurement. Now we are having an issue, the fact that it keeps tripping at a because there's less resistance there. So let's drop this back down and try to pick some values we haven't done before. Now some of these are roughly what we did before, so hopefully I'll edit out the ones which are repeats. Okay, this is now in volts, that's in amperes. Again, volts and amperes. And I sure hope that's enough. Now we're going to measure current, and in order to get the maximum deflection later on, we need to be able to get maximum current. So I'm going to turn the dial up till it is stable enough for long enough in order to be able to get a current and maximum voltage reading. And again, we'll be using this for voltage and this for current. Let's see if I can adjust that slightly. Yep, the glare's off. So let's turn it back on. So aluminum strip, add it again. And I know it's going to be somewhere up here. And that's probably not long enough and really to keep it going, so let's drop it down. So that's probably going to be the stable one right there. So we have 6 amperes flowing through it at the moment, a little more than 6 amperes. It did flip off, but I think it might be stable enough. How warm is this? Well, let's drop it down again. It's definitely seeming stable enough to be able to take measurements in the last part. And now I'm going to set up for the last part. It's twisting like that. I'm trying to get it straightened out. It'd be a lot easier if it's all facing you. It's slightly off up here. So I'm going to adjust this up here. Ooh, it's worse. I want to pinch it at the bottom a little bit, not too much. It is touching there. I think that's probably as good as it's going to get. Yep, and you can see that there's a gap all the way down. It's pretty darn parallel. We need to do some measurements now. I need a ruler. So we need to measure the various gaps, trying to get an average distance here, so when it puffs out, we can have know how much it has changed, because it's the change in the distance that really is going to matter. So let's bring it in. All right, so set up a multi-ruler system here, because doing this solo it's a lot more difficult. I don't want the aluminum strip to touch it at any point, and so there should be a gap there. Oop. Is that? That is a very. Oop. That's a very small gap right there. But that is a gap. All right. And so we're going to do before and after measurements. And so sort of what's the average distance between those two strips there. I'll do one more pass. Then next one. And then down to the third roar. And the fourth one. There we go. And hopefully you can get sort of an average position of the left and right side, and then figure out what the distance, average distance is between them at these points. And pass them back one more time. Now there is some air flowing in the room right now because there's air conditioning, and so that accounts for some of the sway. And then at the bottom, then back. All right, let's turn power on, and let's actually one more scan just to make sure that it's not touching anywhere. Get really close, but there is a gap there. Oh. All right. And now we'll do the measurements again. Second from the bottom. Third from the bottom. There we go. And then fourth from the bottom, or second from the top. And then the top one. And hopefully that is enough. And now let's just do this one more time. First off, I'm going to turn it off and we'll Notice it does come closer to each other. Now we're going to crank it up. So put this thing on 100%. So we should get a lot of current flowing through here. Matter of fact, let's just bypass the meter there. We should have a lot of current flowing through, and so we should get maximum puffing. And it just doesn't last very long, so it's very difficult to do measurements. But let's get this set up. There we go. And hopefully that can be seen well enough. And it is recording. Thank you. So to give you an idea of how much it can puff out, it's just that the breaker trips very quickly. So in theory, you actually could predict what the current was flowing through at that point. We just don't have anything that will measure current that large.